So titration calculations. And there are a load of these in our books, and I will do one of the ones in the worksheets in a bit. But I'll just remind you at this point that in the booklets there's lots of information about how to do a titration, as well as your practical books. You've got a load of notes on how to do titration practicals in the packs I've given you. But a titration calculation, you're using a titration to find out the concentration of a solution that you don't know its concentration. And you can do that because you know the number of moles of the other substance. Let's start with the first titration that we did, which was between hydrochloric acid and sodium hydroxide. And that generates water, like all neutralizations, and sodium chloride salt. And nice and easily in this particular question, the molar ratio, even though it's 1-to-1, we show the examiner we understand that they react in a 1-to-1 ratio. If you want to finish off the ratio, you can do. You don't really need to write anything over here. Now, a titration question will typically say to you something like, it will tell you the volume of HCl, which might have come from the pipette, so that would be typically something like 25.00 centimeters cubed coming from a pipette. And it would tell you the concentration of that HCl as well. It could be the acid or the alkali it's telling you. You should be really carefully fill it in the right way around. But the concentration we used, I think, was 0.10 moles per decimeter cubed. So we've got the concentration, the volume of the acid, and you're told that in the titration, or you might have worked out in an exam question, the mean titer from maybe 3 or 4 titration values, the volume of sodium hydroxide that was used might have been, say, 19.50 centimeters cubed. All right, so we can work out the concentration of this sodium hydroxide really easily, remembering the equation. This is the one thing, the only thing you have to learn really is the number of moles equals the volume times the concentration times volume. And as we said in the previous lesson, the volume in titrations is usually given in centimeters cubed. So we need to divide by 1,000 to convert the centimeters cubed into decimeters cubed, because concentrations in moles per decimeter cubed. So we nearly always use that equation. Okay, so let's just fill in the grid with what we know. It's not the same as the mass calculations where we need MR. We haven't got mass, so it's no good writing down MR. We just write down what we know. We know the volume in centimeters cubed, and we know the concentration in moles per decimeter cubed. So let's fill in that information that we know already. Volume of HCl is 25.00, and it's good practice here to write the right number of decimal places as given in the question. Change that to that. Concentration of HCl 0.100, and we were told the volume of sodium hydroxide was 19.50 centimeters cubed. So we can, just like with any calculation, what is it you're trying to do in any calculation, please? Try to work out the number of moles. If you're not sure what to do, try and work out the number of moles. That's easy to do by doing the volume times the concentration divided by 1,000. This one's pretty straightforward because 25 times 0.1 is 2.5, divided by 1,000 is 2.5. I'm just going to do to 3 sig figs because this is to 3 sig figs, times 10 to the minus 3. So make a note of that. Or if you prefer, it's 0.0025. And just like before, we can use then the molar ratio to work out the number of moles of sodium hydroxide there must have been at the end point, or when they'd reacted together completely. So Jake, how many moles of sodium hydroxide were there? It's the same number, right? And because you're writing it underneath sodium hydroxide, the examiner knows that you understand that the 2.5 moles applies both to HCl and NaOH, being really clear about it. And all we've got to do then is to work out the concentration by rearranging this equation up the top there. It's usually good practice to write down what that equation is. So n times 1,000 divided by the volume is equal to the concentration. So just pop that into the calculator. Number of moles times 1,000 divided by the volume, and that comes to 0.128 moles per decimeter cubed. We'd write it usually in an exam down here somewhere. Okay, that's all you've got to do. Dead simple. And it kind of makes sense. Check your numbers make sense. They reacted in a 1-to-1 ratio. This looks like it's a little bit more concentrated, which is why you need less. Number's a little bit bigger than the other one. Yeah, that sounds like it's gone right. So it looks like my calculation's been done well here. What I want you to do is to do a few of these, but I'm going to do one more with you from the booklet now. So I want you to turn to this page. It says Titrations 1. I'm going to work through this one together. And you'll see here the equation's been given to you, but it's slightly different to the first one. If you haven't got your sheet with you, don't worry, just start writing it on line paper. The information is all here in the question. I'm not going to write it out again, and helpfully the equation is set out nicely here. We can just fill in a grid here. Okay, so the equation's given to you. The difference here is important, isn't it? Why is the difference here important? Well, I see some of you waving, but I'm going to say it's a 2-to-1 ratio, and that's going to change what we do when working out the number of moles. Okay. Now the tricky bit here is to fill in the grid correctly. So the volume in centimeters cubed. We must get the volume for the right substance. So the volume of barium hydroxide is 25.0. And the concentration of barium hydroxide is 0.200. We'll work out the moles shortly. And we're told we've got 22.8 centimeters cubed of hydrochloric acid. Okay, we're going to calculate the concentration of hydrochloric acid using exactly the same method I've just shown you. Difference being it's a 1-to-2 ratio this time. And I've also added a little bonus question, which the exam board like to do sometimes, which is to also give it in grams per decimeter cubed as well. So we'll do that afterwards. So let's start by working out the number of moles of the barium hydroxide by doing C times V divided by 1,000. Concentration is 0.2, volume is 25, divided by 1,000 comes to 0.005, or if you prefer 5.00, which I do, times 10 to the minus 3. Now we need to work out then how many moles of HCl there are. This is a little tiny bit different from before, isn't it? So what do I have to multiply it by? Show me with fingers. How many what do I have to multiply it by? Yeah, everyone's doing 2 fingers at me for some reason or other. Multiply by 2, and that's 0.0100, or if you prefer 1.00 times 10 to the minus 2 if you're sticking with standard form. We could just work out the concentration by doing n times 1,000 divided by the volume. It's always worth sitting in an exam. As soon as you start doing the exam, you can write on the front cover, or as soon as you're told to start, you can write on the front of the exam paper, in your paper 1 in summer next year. You can write down these equations so you can refer back to them. So you do that value, which is 0.1 times 1,000 divided by the volume, which is 22.8. I get, I hope I got this right, 0.439. Being careful to round up. It says in the calculator 0.4385. I've rounded up to 0.439. Not that easy to read, so I'm going to write it over here for the examiner to be really clear that I know what I'm doing, and I've written it to the right number of significant figures, which it's told me to do in the question. If you get that in a question, that is worth a mark. It tells you to do it to 3 sig figs. You must write it to 3 sig figs, otherwise you're going to lose a mark there. A really easy mark, or gain a really easy mark, if you put it that way. And then finally convert to grams per decimeter cubed to remind you of that skill. moles per decimeter cubed to grams per decimeter cubed. To get from grams to moles, what do? No, think about MR here. Moles equals mass divided by MR. So you do that way, you divide by the MR, that way you times by MR. So times that by the formula mass of HCl, so 0.439 times 36.5 will give you the answer in grams per decimeter cubed. I'm not going to do that. I'm going to stop the video and let you get on with subsequent questions.